Hi everyone. In this hands-on, we are going to do our next Hello World. If you remember from our last one, that's currently documented on the website, we got to look at how void setup and void loop are structured. If you remember, we created just a simple code that we uploaded to the Arduino board where when it stepped into void setup, it printed a line saying that it was something to the effect of in setup, and then it would step into void loop and repeat that, also saying something to the effect of we're in void loop. We're going to do our next hands-on where this time we are going to use the Arduino board to do something similar, where this time we're going to have a light blink. Again, this is a very simple exercise, but hopefully it'll allow us to understand how the different ports work, the different output ports, a little bit of how to use our breadboard, as well as, again, getting a little bit of exercise with the Arduino code, especially with void setup and void loop. So right now I have everything disconnected, including my USB, my Arduino board, and for this hands-on, as documented on the website, you'll need an LED, a 220 resistor, and I'm using a couple of jumper cables just because it'll make my life a little bit easier. So we're going to start with the hardware first before we move into the code. So that's why you'll see the code is just kind of smaller right now. So let's walk through some of these things. So just as a reminder again about the Arduino board, I'll try to get it closer to the camera. I'm using an Uno. Yours may look a little bit different depending on certain configurations. For instance, mine has the older USB. Some of the newer ones, like if you get it from Adafruit, it uses a USB mini or micro. I don't remember, but it's a smaller one. This one has the bigger one. Has a little barrel jack for power. And all that. But again, everything is done on board. A few things to just kind of point out again. As a reminder, our analog pins are here. Our digital pins are on the top. The digital pins are high and low, 1 or 0 only. Analog, you can get a little bit more fidelity and fine grain. And then our power pins right there. We have a couple grounds. We have a ground that's in the digital pin side near the top, as well as a couple down here at the bottom, down here, and then our 5-volt. And we'll talk a little bit more about that. So our LED, let me actually get a piece of paper so you can kind of see this a little bit better. So we're going to be using a red LED for this. You can use any color that is handy to you: red, yellow, green, blue, white, whatever's in your kit. You may have an RGB LED. It'll have an extra pin. We won't be using that for this just because it requires a little bit more. But it's a little diode that in the circuit will emit light, hence the name, light emitting diode. Something to note though is that it's polarized, and how you know this is that one pin is longer than the other. You can see that this one's a little bit longer than this one. This tells us that there's directionality in this. So we'll want the longer pin towards our power source, at least in this circuit, how we're setting it up. If you do it the other way and you have the smaller pin towards a power source, either it won't work, nothing will happen, or depending on the voltage, you may end up blowing the LED. But, that shouldn't be so bad. These are fairly, cost effective. That's why we have them everywhere in the world today. We also have our little resistor here. Mine's a little bit beat up and worn. We're going to be using a 220 resistor, 220 ohms. If yours is a little bit mixed up, you'll want to look at the colors. Let's see if I can get it closer to the camera there. We'll be using red, red, brown if you're trying to look at the colors. But that's why you may want to keep them organized with their labels, just so that you don't have to try to sit there and match all the colors. Again, we're going to be using a couple jumper cables, and then we'll be using our breadboard. So as a review, mine's a little bit more intense than yours, but it's exactly the same, I promise, just more of it. How it's structured is underneath the plastic here, you can see that there's a group of 5, a row of 5, and then a plastic break, and then another row of 5. Basically, how you should read it is that each row of 5 is all the same, like one pin. Literally underneath the plastic, there's a piece of metal that connects that row of 5. And then there's the break in the middle. So the 5 isn't connected over the break. So it's 5 and then another 5. So if you were to do a circuit, that counts as one, and then that's a separate one. Some of you may have ones with vertical bands on either side with 2 columns on each side. Very similar to the ones with the 5, but each column is connected. So the piece of metal goes vertically down. And then I have some at the top that are very similar that go horizontally, but the bands here, what we'd usually do is we treat one as power, one as ground. So you would have maybe power, ground, and then similarly on the other side, power and ground. So you don't have to necessarily go back to your board. If you connect your board to just these sides, you can connect everything in and out from there. The vertical columns are not connected to each other horizontally, so that means one column is just, power, however you want to set it up. The other one is just ground. Or maybe more power, depending on how you set it up, but those verticals are treated as one. So you do want to be careful when you're plugging in, that you're paying attention, that you're not kind of sticking it in the same row or the same column when you're not meaning to, because then, you might short something. And we'll kind of go through that once we go into the hardware. So we're going to hook up our LED. I'm going to set this down, but all the documentation is online, and I think right now I'm going to pop up the circuit diagram and put away the Arduino code until we need it. So we're going to start with our LED, again, polarized. So we're going to start with the longer pin. And I'm going to just work on this far column just for the ease of keeping everything tidy. And hopefully you'll be able to see. But I'm going to just start somewhere near the top. I'm probably going to use the 3rd or 4th row here just arbitrarily. I'm going to try to keep things kind of tidy just so that you can see. But I'll stick the long pin in about the 3rd row and the short pin in the 5th row. Again, we're going vertically, not horizontally, because if I stuck it all in the 3rd row, it's as if I just soldered the legs together, right? So now that anything goes in or out are basically going into the same pin. So again, we're going to go vertically. I'm going to do 3rd row, 5th row, just for space. And you insert it, it's in. I can feel that it's in. Great. So then I'm going to take my resistor, and this is not polarized. The legs are the same size. It's a little worn, so this might be a little hard to put in. And I'm going to stick one leg into the 5th row, so the short leg of the LED. Let's see. I have to get a little closer here. There we go. And then I'll just have the other leg just going down to another row. Now, in our documentation, in the diagram, I think you have it so that it's jumping over the chasm. Again, that's the same because the 2 sides aren't connected. That's the same as just jumping down a couple rows. I have mine going down to something like row 15, only because the legs of my resistor are so long. It doesn't really matter where you put it. You can have it kind of a little bit taller, but just because of how long the legs are and I don't want to trim them, I just have it going down quite a bit farther. But you can just jump over the chasm. And again, these worked horizontally as well. So now we're going to bring in our Arduino board. This is not wired yet. No power is going into it. So let's start with our power. So the red jumper cable. Again, these are male to male. So we can just kind of insert them where we want them. So I'm going to have power going to that first leg. So I'll just stick it in column 1 of, in my case, that was row 3. And let me just talk about kind of the circuit for a second. So I'm going to stick it into, ultimately, our digital pin as in our diagram. And I'll explain why in a second. But for instance, I could also stick it in 5 volts down on the lower end in our power. So 1, 2, 3, 4, the 4th one in, I think. And if this was connected into a circuit and I had power going in, we'd just be sending 5 volts in, which would keep the light on. It's not kind of doing any modulation. It's not doing any control. It's just on. So that's a good way to see if power, but frankly, there are other LEDs on the board that act in the same way. That if you see the light, it's acting in the same way, just connecting straight to power and is on whenever power is going in. We're not going to do that. just because we do want to do some control. We're going to make our LED blink. So we're going to put it in this case, we're going to put it in a digital pin, digital 5, kind of picked arbitrarily. Let's see, 0, 1, 2, 3, 4, 5. And then you can pick any of the ground pins. I'm going to just pick it on the other side just to keep it tidy. But remember, there's also a ground pin up here as well. And I'm going to stick this to the second leg of our resistor. There we go. Oops, I think I might have knocked out the resistor. Hopefully I didn't. Okay, so now we are going to go into the code. So just as a reminder, we have a void setup and void loop. Setup we'll only go through once, and then void loop will run repeatedly. As a refresher too, I'm using the desktop IDE. You might be using the cloud-based IDE. There are small differences in how they start with a blank template. Just to kind of bring us together, I'm going to create a code block here, a comment block. If you're going to do a block, you can do /*/ to close it, or you can do the double slash, but I'm going to just call this is our blinking LED hello world. Now we're going to step in to void setup. And what we're going to need to do is we're going to set up our Arduino board. Like, we need to tell the computer how to talk, or how the board needs to talk. So we're going to initialize pin number 5. Again, that's our digital pin. So we are going to say that we need to set that up with pin mode. And in this function, with this little helper, you can kind of tell us, it'll tell us what's needed. We need to tell it the pin. So in case this is 5, if you use a different pin, you just put a different number. And then what's the mode that we're going to do? We're going to do output. And semicolon, because we're in a Java-based environment. And then for void loop, what we're going to say is that to that pin, to pin 5, the output is going to be a high, which is on. So we're going to say send all the voltage. So digital, right, because we're using a digital pin. 5 high. And then we are going to tell it to wait 1,000 milliseconds with delay. And then let me just complete this. And then we're going to ask it to turn off. And delay again. So what this loop is going to do is we've done that once. The pins are active. And then the microprocessor is going to write to pin 5 high, which is on. And then it's going to wait 1,000 milliseconds. So it's going to wait 1 second before it goes to the next command. So that means our code will be stuck, quote unquote. We'll be still sending a high signal for 1,000 milliseconds. And then we'll send a low signal for 1,000 milliseconds. And then we'll go back to high. So if we're going from high to low with a 1 second delay, we're blinking it on and off at a 1 second interval. We can upload this code as it is. It'll work perfectly. But as we get into more complicated code, we may want to do things into our code. We want to insert things to help us see what's going on. For instance, we may want to be able to see where we are in the code, what the outputs are, for instance, a sensor output. And we will want to be able to see. And it'll also help us troubleshoot. So if something's broken, we can see how far the code got before it broke. So we're going to do that. We are going to do something that we did before, and we are going to activate the serial port. With a 9.6K or 9,600 bauds per second. BPS. So we'll be very low amount of data coming through, but we're going to open the serial port. And then in here, before we delay, we're going to ask it that after it sends a signal of high, we're going to tell the serial port to just print a line saying that our LED is on. And then very similarly, I'm going to just copy it here. Oops, there we go. And we're going to tell it to tell us that it turned off. So, for instance, if this section, if our off is broken, we'll see that our LED turned on. I mean, this will be pretty easy because we'll see a blinking light, right? But we'll see it turn on, and then once it turns off, it'll tell us. And if it never turns on and it never says on, we know that it might be a problem elsewhere. So for instance, if the LED turns on, but we don't see it on, that might be a communication error with the computer. If we don't see it turn on the board, but we get the code saying on, we'll know that probably there's some hardware issue, and that might be something like we have a short or we blew the LED or whatever. So this will just kind of give us little clues as to what's going on. Now that we're ready, let's hook everything up and let's upload, and hopefully we'll see it works. I'll also turn on the serial monitor as well, just so that we have that kind of output going in. I don't know what code I have on here from previous, so if it's blinking, it might be from the previous code, but let's see what happens. I'm doing this live, so if there are any issues, I will be troubleshooting live and recording it all. So. All right, I'm sticking the USB into my computer now. You can see it's communicating. So let's see if we can get it working. You can see that I had some previous code, but you know, I'm getting the off on. So hopefully that's not a bad omen here. So now let's upload the new code. All right, so you can see that we do have a problem here somewhere. Oh, you remember when I said the resistor might be out? That's the exact issue. So let me stick it in. There we go. Resistor's back in the pin, or back in the hole, and you can see that it's blinking with an interval of 1 second. And if you can see in our serial monitor that we have things going off and on, which is great. That's exactly what we want to look at. And you see exactly, it was not intentional in this case to have the code supporting us, but seeing kind of the off and on, but not seeing the LED, that told us that the problem is hardware, and I can actually go very quickly and just kind of see what the issue was. And in that case, the bottom leg had popped out of the hole when I was trying to do those adjustments. So here we can already adjust. So let's say I want this to be shorter. So I'm adjusting the code to do off for a shorter duration, only half a second, 500 mils. Let's upload it, and it should be blinking very soon with a different frequency. There we go. So that is our hands-on tutorial with our LED with our Arduino. Hopefully you've had success and that you have a cool little blinking LED. And in module 4, the next one, we will be playing with an input connecting to the serial port with our hardware. And I'll see you in the next one.